So, last time, we were talking about the reproductive system, about the fact that it has the least to do with homeostasis compared to our other systems, about the fact that it has a few different key functions regardless of whether we're talking about female or male, because it's going to produce the gametes through a process of meiosis, that specialized cell division where we're kind of tearing cells in half, if you will. We said also there's going to be a series of other organs, accessory organs, and tubes and stuff like that support the gametes in some way, transport them or protect them or give them things they need, etc. And then also the third function for reproductive system, whether it's male or female, is to produce the sex hormones. When we get to female reproductive system, we said that it's going to be a little bit more complex, where we're going to, in essence, the site of fertilization is going to be inside of the female reproductive tract, and then development and the support of the embryo and fetus is going to be also taking place in the woman's body. So that's going to be a little bit different as well from what we've seen already in terms of male reproductive system. So that's something that we'll be talking about. Okay, so this is basically where we had left off. Okay? So we had looked a little bit at this figure in terms of oogenesis, but we also looked at this figure. Right? And this one is showing us an ovary. It's showing us a finger-like fimbriae around it. We said it's like a catcher's mitt. And then that leads into the uterine tube, also known as the fallopian tube. In this one, it's labeled follicle maturation. Last time we discussed the fact that a follicle is a combination of two things, right? So what's a follicle? What makes up a follicle? So so it's going to be the oocyte of the egg that we see inside of all these different follicles, and then it's going to be a layer or two or more of follicular cells that have some sort of function along with the reproductive system. And so we said that one thing that is very different between male and female reproductive systems and gametogenesis in the two is that spermatogenesis, so out of one cell, through two different meiotic divisions, we end up with 4 cells, each haploid, right? They only have 23 chromosomes each, okay? So we said that that is basically a continual process where we are making those from the time where sexual maturity starts, like whatever, 10, 11 years old, through the rest of the lifetime, right, of the pubescent. So years and years and years and years that production is going to take place on demand. Oogenesis is quite different. We said that all the eggs, i.e. gametes, that you are going to have, you already made before you were born. And so they are stored in the ovaries, and they are released, let's take back that, they mature, and then are released on a very regular schedule, right? On average, 1 per month. So there's a set of these, what are called primordial follicles, the smallest ones that you see on the diagram. Most of the follicles that you have in your ovary are going to be primordial. They're just sitting there waiting for their particular chance for receiving the hormonal stimulation that tells them that it's their turn to develop and to mature a bit. So when we look at these primordial follicles, this one right here might have a date of, May 2014. That's going to be its turn. And this one over here is going to mature in, June of 2027. Right? They're already there. They're just waiting for their turn. And so there's sets of about 5 to 10 of them that will start this developmental process that takes a series of months for them to get more mature, get bigger, etc. And then by the time it's their turn, that 5 to 10 that we started developing, only one of them will complete that process. So what this figure shows us is kind of a time here. It doesn't spend time there. Inside of your ovary, it's not staying for little time. It's not got to be like that. Okay? They're showing you that in the ovary, there's this process of development, of maturation of these follicles. So, the primordial ones that we see over on the left-hand side, there are hundreds and hundreds, if not thousands of those that are in the ovarian cortex, just sitting there waiting for their turn. They couldn't drop them all in there because you wouldn't be able to see anything else. But if you look at the microscope slide, in the microscope, you'll see just all these little ones sitting right there at the edge. Now, A subset of those, a number of sets of those, will be in different stages of development. What they do is they go from a primordial stage to a primary follicle. You can see how it's gotten a bit bigger. The egg in the inside has gotten a bit bigger, as well as those surrounding follicular cells. And then they become what's called the secondary follicle as well, right? So it's like the second developmental stage. And these ones that you see here are secondary follicles. And you see that fluid, or that blue space right there? That space right there is called an antrum. And so when we see an antrum like that, that fluid-filled space inside of the follicle, we know that it's now graduated to a secondary follicle, okay? And so, you know, of the, say, if we had like 10 primordial follicles that start this process, maybe 7 might make it to become a primary follicle, and maybe 3 might become a secondary follicle. And those other ones just kind of waste away and get reabsorbed, okay? And so ultimately, there's going to be one of these follicles that ends up winning a developmental race, and that's the one that's going to release its egg from the surface of the ovary, like you see there, in a process that's called ovulation. Okay? So the egg breaks out of the follicle itself and is gathered up by those fimbriae that we see here, and then it starts making its way down the uterine tube to potentially be fertilized by a sperm if the sperm happens to be there. Okay? Okay, now the follicle, we know that the follicle is going to be made up of the egg, or the oocyte on the inside, and these surrounding follicular cells. Now those follicular cells, you know, they kind of look like, oh, maybe they're protecting the egg, they're just surrounding it, or something like that. They do have their own particular role. So when the egg is released at ovulation, those surrounding follicular cells become this big cloud, this yellow cloud of cells that's called the corpus luteum. So corpus means body, like corpse, and luteum means yellow. And so the corpus luteum is the yellow body, and it has a very important role in that the corpus luteum secretes mainly progesterone, which is one of our 2 female steroid hormones. Okay? Now we know that hormones, they act as chemical messengers. So if we're putting out a hormone, that's a message that's supposed to go somewhere. It's supposed to stimulate some other organ or something like that. So we've got to keep an eye, or at least our mind, on the fact that all of a sudden, that corpus luteum, after ovulation, the ovary is starting to signal some other organ in the body with this peak of progesterone there. Now, prior to ovulation, those follicular cells are also active. Those follicular cells, as the follicle gets bigger, etc., they're putting out estrogen at the first part of the cycle. So in the first part of the cycle, these follicular cells, as they're getting bigger and we're getting more and more layers of them, the first part of the cycle, of what we call the ovarian cycle here, is where we see estrogen levels increasing and increasing because there's bigger and more of these follicular cells as these sets of follicles are developing. So we see estrogen levels going up this part of the cycle, then ovulation occurs, and then when those follicular cells become the corpus luteum, we see progesterone levels spike in the second part of the ovarian cycle, or technically the third part. The ovulation or the release of the egg from the ovary counts as a middle phase of what we call the ovarian cycle. So it's actually 3, and we'll see that coming up. Okay? So this development of follicles with the oocyte, the egg in the inside, is happening on a very regular basis. But we're not producing these cells each month. We're just stimulating sets of these cells so that they're ready to be, at least one of them, released on a monthly cycle. So it might be coming from that ovary, it might be coming from this ovary, etc. And there are actually people, women, who can feel the ovulation occurring. There's a name for it, like a German name, it's like Mittelschmerz. But basically, you know, the egg erupts from the surface of the ovary. And in fact, if they do microscopic viewing of it, if they take a camera and they look at the surface of the ovary, they can see all the different stars from where the eggs have ovulated. So again, if they're looking for problems in terms of conception and stuff like that, they're looking at the male, and we're talking about sperm count and various things like that, but then also they'll look at the female, so they'll go look at the ovaries and see if the ovaries have been releasing eggs, check the hormone levels to see that the hormone levels are increasing and decreasing the way that they're supposed to, etc. Okay? So some people can actually feel that pain. So I had a student a few years back who, after getting on this lecture, she came up and told me that she gets that pain, and it's significant enough. It's just like kind of a short cramp. hasn't happened, but she gets it significantly enough. She can tell which ovary that the egg is coming from when it happens. So that's pretty darn good. She is looking to get pregnant or looking not to get pregnant because she knows exactly when that egg is being ovulated. In any case, this is happening on a monthly basis, right? So that's what we're seeing happening inside the ovary. Now, in terms of the development of these oocytes way back when, they still have to go through meiosis, much like we talked about the sperm cells going through meiosis. Now, again, with sperm cells, we started out with one germ cell that was diploid, 46 chromosomes, actually duplicated already through mitosis and interphase, and then it divided twice. It gives 4 cells, each of 23 chromosomes. Now, look at this, right? So we had, in spermatogenesis, we had a primary spermatocyte that would divide in a first meiotic division and become a secondary spermatocyte. So the naming is kind of similar here. So we start out with a primary oocyte. This is just the egg. We can see the chromosomes inside of it like that. They're kind of winding up. Remember that meiosis is kind of like mitosis, except for we go through all 4 of those phases twice. We go through prophase, metaphase, anaphase, telophase twice. Okay? So rather than ending up with 2 cells, each with 46 chromosomes, we end up with 4 cells, each with 23 chromosomes. So here is our diploid cell. For a human cell, that has a full set of chromosomes, it's got 46. At the first meiotic division, if this is sperm, we'd basically be tearing the cell in half. We have 2 smaller cells, each would have 23 chromosomes, but 2 copies of those 23. Okay? Now, let's look at what's going on in oogenesis. So the first meiotic division, we do get 2 cells, but they're not exactly the same. In spermatogenesis, when we do those divisions, the cells all look the same. Okay? Through oogenesis, we have what's called asymmetrical cell division. Asymmetrical means they don't look the same. So what we have is one cell that becomes the secondary oocyte, and it actually takes, if you want to call it that, the lion or the lioness's share of the cytoplasm, the organelles, and stuff like that. And you can see that that secondary oocyte is almost the same size as the primary one. Okay? The other thing that is produced, we almost wouldn't even call it a cell. It's called a polar body. And this is much smaller. You see it has sort of the stick in terms of organelles and cytoplasm and stuff like that. But this polar body never becomes anything. It doesn't become an egg that could be fertilized. It doesn't do any other divisions usually. It doesn't become anything that's functional. It's not a functional oocyte or egg. The reason that this is here is that we have to get rid of these extra chromosomes that we duplicated. Okay? Just like in the meiosis for spermatogenesis, we go through this big duplication event. But at the end of this process, we need a cell or cells that have one single copy of 23 chromosomes. So that when the sperm contacts the egg, we have 23 plus 23, we're up to 46 again. We don't want extra chromosomes, that gets weird. Okay? So, this is a way for us to ditch one extra set of those chromosomes that we duplicated. So now we have 23 duplicated chromosomes there. Okay? So that's our secondary oocyte. So we produce a polar body and a secondary oocyte. Now that secondary oocyte, at that point, like when we see the primary, the secondary follicle, etc., that's where we see the secondary oocyte kind of finishing that first meiotic division right before ovulation. So it finishes the first of 2 rounds of meiosis right before ovulation. So there's years and years and years that follicle is sitting inside of the ovary, right in the middle of the first meiotic division. It just stops, and it's like frozen there. Okay? And then if it gets the hormonal stimulus to develop, like, hey, in a couple months it's going to be my chance to maybe be ovulated, then if it gets to the end of that maturation process, it will complete at least the first meiotic division. Okay? But we know that there's 2 meiotic divisions, right? 2 times that we carry it now. The second meiotic division for an egg only occurs if fertilization occurs. So for most eggs that you have in your ovaries, a lot of them won't even complete the first meiotic division because they won't complete the whole maturation rate. They'll get reabsorbed and stuff like that. And even for the ones ovulated each month, only if that one becomes fertilized with the sperm cell will it complete a second meiotic division. Okay? So you see the sperm cell coming in on the right-hand side there where it says fertilization. That's the stimulus for it to complete its second fertilization or second meiotic division and get rid of that extra copy of those 23 chromosomes that it's carrying. So after that second meiotic division, what we get is a zygote, which is the term for the fertilized egg, and a second polar body. Okay? So let's compare what we saw in spermatogenesis with oogenesis then. Spermatogenesis happens all the time, on demand, etc. Start out with one diploid cell and up with 4 haploid cells. So that way we can supply, right, the 600 million sperm that might be in one ejaculation. But for this process, all of the production of the eggs takes place before you're born. They mature only after chemical stimulation, hormonal stimulation that gets them to go, maybe 10, 20, 30 years later. When they divide and they do this ripping, this meiotic division, it takes only after fertilization occurs for them to complete both rounds of meiotic division. And at the end of this process, we started out with one diploid cell, and at the end of oogenesis, we get one egg that is fertilized. That's it. So there's no amplification and things like that like we see with spermatogenesis, but it doesn't matter. Spermatogenesis is a numbers game. It's a numbers game because, as we'll talk about with the process of fertilization and stuff like that, there's a lot of those sperm cells that aren't going to make it. So there's a lot of the sperm cells that may die as they're going through the acidic urethra or something like that, or the acidic vagina. There's actually white blood cells in the woman's body that will attack the sperm cells because guess what? They have foreign antigens on the cell surface. That woman's body does not recognize those cells, and so there are immune system responses to those cells when they enter the woman's body. Okay? So there's attacks that they go on at that level. There's a lot of sperm, or a number of sperm that are malformed. Maybe they have no tail, so now they can't swim. Maybe they have 2 heads. Maybe they have 2 tails, and they go in like circles and stuff like that, right? So they're not going to make it. And then think about this, right? All along the way, to get deposited with the vagina, they have to navigate to the cervix, up through the uterus, and then once we get to the uterus, like if this is the uterus, these are the fallopian tubes with the fimbriae like this, and then here's going to be the ovaries on either side, right? If they're coming up this way, at this point they're getting to a Y intersection. They're going to go that way, they're going to go that way. If they go the wrong way, on a monthly cycle, it's only one of these ovaries that's going to be releasing an egg. So a lot of the sperm are going to be going the wrong way, and there's no egg that they're even going to contact, even if they get that far. So it's a big numbers game for sperm, but for eggs, we're only releasing 1 per month. So we don't have to worry about making a ton of them. We only have to release 1 per month, maybe 500 over your reproductive lifetime. Okay? So one of the important reasons that we see this asymmetrical division is, like we said, the egg itself as a gamete is going to be the home, it's going to be the house for the developing embryo, etc. It's what becomes the zygote. The head of the sperm goes into the egg, and then that is really the starting of the new diploid stage, of the new individual. So that's why we need this egg to have so much cytoplasm and organelles and stuff like that, because it's going to supply the home for this zygote, this first big cell. Okay? So we need to make sure that when we do these divisions, we give it most of the organelles, the cytoplasm, etc., so that it has a lot of this material to be this first cell called the zygote. Okay? So the reason we have to go through the divisions is we have to get rid of the extra copies of the chromosome material that we get when we go through meiosis. But we want to make sure that that cell, the secondary oocyte, and then finally what will become the zygote, gets most of the cellular material when we do those divisions. Okay, so it's pretty different, huh? Alright, so we said that those follicles get stimulation, or we can handle of them, get stimulation when they're turn to develop. Well, once upon a time, when we were talking about the male reproductive system, and we talked about the hormonal control, because there are two, what they call gonadotrophic hormones coming from the pituitary gland. One is called follicle-stimulating hormone, and the other one is called luteinizing hormone. Okay? So we explained that those two hormones in the male go down and tell the seminiferous tubules to produce sperm, and they go down and tell the interstitial cells to produce testosterone. They have two separate functions, one for hormones, one for producing sex cells. They have the same role in the woman, but their name comes from their function in the woman, so it makes much more sense now. We have a hormone coming from the pituitary gland called follicle-stimulating hormone. Oh, that's what it means. It goes down and it tells a small group of those follicles that are sitting waiting for their turn to start developing, to go from primordial to primary to secondary, etc. Okay? So that's what follicle-stimulating hormone does. Follicle-stimulating hormone in both males and females stimulates gametogenesis, or at least development, etc. Okay? Okay. So that will get the follicles to mature inside of the ovary. So that's what we see happening here. That's the signal. Now, we said as those follicles develop, as they get bigger, those follicular cells are going to release estrogen. That's going to be important as well. We said that estrogen is also a hormone, so that means it's going to be communicating with something else. And that something else that we'll see coming up is going to be the uterus. Because that's one of the ways that the female reproductive system gets more complex, right? We've got an organ that is responsible for producing sex hormones and gametes. Pretty much the same, pretty much in certain ways, as the gonad in the male, the testes, right? But we also, in the female, have this other organ, the uterus, whose role it is to support the potentially developing embryo and fetus, etc. So each and every month when this cycle is going on in the ovary, they're saying, okay, we need to have a mature follicle release an egg at ovulation. Every time that happens, the uterus has to get ready in case fertilization happens. So it has to be very well supported, a nice, supportive, physiologically supportive environment in case this zygote and this early embryo arrives at the uterus and needs a place to implant. So that's where that implantation occurs, is in the inner wall of the uterus. Okay? So each and every month, the uterus has to prepare for the possibility that pregnancy occurs. And if it doesn't occur, it's going to reset in terms of the clock, just like this resets every month. It releases an egg, the follicular cells turn into the corpus luteum, starts secreting progesterone, and if pregnancy doesn't occur, that corpus luteum starts to kind of wither away, if you will, turns into a white body, the corpus albicans, like you see there. So albicans is like albino, that's the white part, white body. And so then, the cycle will go again, where we'll have another set of follicles that are maturing to be ready for the next monthly cycle, the next release. Okay, so like I said, ovulation is where that secondary oocyte is released from the cortex of the ovary, and it's going to start migrating down the fallopian tube. Okay, now if it doesn't get fertilized, which most times it doesn't, right? If it doesn't get fertilized, it basically degenerates. We said that both the ovary and the uterus kind of go through a reset cycle, and that egg that's been released will also just kind of degenerate along with some of the inner tissue of the uterus. Okay, so we'll talk about that. So now what we know is how the gonad in the female produce and mature the gametes. Okay, how it gets released. That's kind of the point that we took it up to in terms of the male reproductive system as well, right? We talked about the gonad, how they create the gamete, how it goes through maybe a series of tubes, etc. Then the male is more kind of glands and stuff like that as well that help and support the sperm or the gamete. And then we kind of stopped there. We said, okay, we may be heading towards each other, but we stopped the story there. Before we continue that story and talk about what happens at fertilization, etc., we have to finish talking about the accessory organs for the female. Now, there's not quite as many, but we also mentioned that for some of them, particularly the uterus, they're going to be much more important, at least in terms of the function of the reproductive system in creating another new individual. Okay. So, female internal accessory organs are going to be a pair of uterine tubes, also called fallopian tubes, if you want to call them that, the uterus, and the vagina. So this looks pretty much like I was showing you, right? So this is an anterior view. So we're going to say here's the vagina down here, here's the opening of the uterus that we call the cervix, and here, all of this is uterus. Okay, you can see it's bigger up here, there's a big curve up here. It has the same type of name as the stomach. There's an upper curve of the stomach called the fundus. The main part is called the body, and then there's a part that it narrows down here, it's called the isthmus, before it gets down to the cervix. Okay? They actually are showing you by cutting it away that there are 3 layers to it. There's an endometrium on the inside, a myometrium in the middle, and a perimetrium on the outside. We're seeing the same use of the prefixes and stuff like that before, right? Like endocardium and myocardium, etc., and pericardium. Okay? So, it's that endocardium you see there, which is going to be so important in terms of being a supportive environment for a fertilized egg or a zygote. So we'll talk about that coming up. But we can see here where the ovaries are naturally the size, and there are various ligaments that support both the uterus and the ovaries and the uterine tubes and stuff like that within the pelvic cavity to make sure that they, if you will, hang right in the right places. We can see the ovary here, releasing the oocytes picked up by the fimbriae, going to the kind of wider part of the uterine tube called the infundibulum, and then it's going to migrate its way down here. And then by the time it gets down here, the uterus is darn well needs to be ready for the potential that egg is fertilized and is starting to kind of grow into a new individual. Okay, so the vagina is going to be where the sperm are going to be deposited. We said that the sperm are going to have to go through the cervix right here in order to migrate up into the uterus, in order to get up here to the uterine tubes. And in fact, fertilization most of the time occurs in that first third of the uterine tube. So there's a timing to it, right? You've got to make sure that if the egg hasn't been released from the ovary, it doesn't matter if sperm have made their way up here. They can't make it all the way to penetrate the ovary and like fertilize the egg in the ovary. It doesn't happen. It has to be released from the ovary, and it has to be somewhere in the uterine tube right here. Now, as it gets fertilized here, it continues migrating down, we'll see, and then it embeds in the uterus. And the uterus provides, like I said, a very supportive environment for it. Lots of blood supply, and nutrients, and things like that. You do hear about ectopic pregnancies, where that implantation doesn't occur in the uterus. So maybe it occurs actually up in the uterine tube, or even outside the uterine tube, etc. In those cases, the developing embryo doesn't have a very substantial kind of hold or foothold in attaching to the wall. It's not as good as if it was in the uterus. And the uterus is built to be able to expand, as you know, as the baby gets bigger. So it continually, for 9 months, provides a supportive environment. The uterine tubes can't. So while, the embryo may be able to grow a bit up in the uterine tube there, it's not going to be able to stay there because the uterine tube just can't get big enough and be supportive enough like the uterus can. Okay, so these are the internal supportive structures. So the external accessory structures we mentioned previously, right? So we've got all of these up here are collectively called the vulva, and we have the clitoris, like we saw, which is analogous to the penis. So this is the erectile tissue there. In terms of the male reproductive anatomy, right? That is analogous to the penis, and then the labia minor on the inside, and the labia major on the outside. In terms of the male anatomy and development, under the influence of testosterone, these will actually seal together. And so it's not going to be any opening, right? It's certainly not going to be any vagina. There's not going to be any urethral opening in between them. It's going to seal together underneath the scrotum. So it's going to kind of sew together there. And then, of course, the clitoris is going to get bigger. The urethra is going to be routed into it. And that is how we're going to have a male external anatomy as opposed to female. And it all depends on if you have an X chromosome or an X chromosome or an X and Y chromosome. If you have a Y chromosome, there's going to be what's called a sex-determining region on that will cause the early gonads to develop in the testes, which will release testosterone, which will start routing this And it's not in this form yet, it's early form. It will start routing that fake female form into a male form in terms of the internal and external anatomy. Okay, so now we can look at this whole process and how it's coordinated to do these monthly cycles, both in the ovary and in the uterus. So the ovary and the uterus have to be in sync every single month, because the ovary has to make sure that there's an egg out of one or the other that's going to be released, and has matured enough to be released, and the uterus has to be ready every single month for the possibility that that egg that's been released might get fertilized and might need a place to stay, right? So it's like getting the guest room in your house ready every single month, just in case whatever, your friend's going to be coming. So every month, you're like, oh, great, they come in, now I got to take the sheets off, I got to dump, I got to vacuum, stuff like that. And now they might be coming this month, so let's wash all that stuff, put it all back, get it all ready. Every month, that's what's going on in the uterus, okay? Okay. So let's look at those hormones again, just like we did in terms of the male reproductive system. So we said that the hypothalamus controls the pituitary gland. And the pituitary gland then releases luteinizing hormone and follicle-stimulating hormone starting at about 10 years of age. Okay, so once that follicle-stimulating hormone starts coming down to the ovaries, that's when the roots of follicles start developing. And it takes a number of months for those sets of follicles to develop. So in fact, when you start getting these surges in follicle-stimulating hormone, it'll take a while, a few months or so, before ovulation, the first ovulation will occur, and the first menstruation, etc. And it takes a while for those eggs to develop, those follicles to develop, and the follicles we then are secreting hormones that are actually going to communicate to the uterus. But in any case, follicle-stimulating hormone gets those follicles developing. Luteinizing hormone, we will find, luteinizing sounds like corpus luteum, and we know the corpus luteum is what those follicle cells become after ovulation. So the luteinizing hormone that we see there is in charge of causing those follicular cells to turn into a corpus luteum. Okay, so we'll see that coming up. Okay, so follicle-stimulating hormone causes the development of the follicles. As the follicles get bigger, there's more follicular cells, they are producing estrogen. So estrogen levels are going to go up. Now, just like in the male reproductive system, there is a function in terms of the reproductive function, but then there's also the development of the secondary sexual characteristics from the sexual steroid hormone. So in the female, secondary sexual characteristics are going to be breast development, increased adipose deposition, right, hips and things like that, and then increased vascularization to the skin, etc. Okay? Now, we also said that the ovaries are going to produce progesterone, but that occurs after ovulation, after these follicular cells turn into the corpus luteum, and that's going to be important in communicating with the uterus as well. Okay, so we've got two organs that are doing monthly cycles. An ovary doing an ovarian cycle, and a uterus that's doing a uterine cycle. But they need to be in sync with each other. So that's going to take us to, and when we see menstrual cycles like that, that's referring to the uterine cycle, what's going on in the uterus each month. So that takes us to this figure. Yeah, very exciting. Lots of colors, pretty lines, and things like that. So this figure is one similar to it in your textbook. I think I took this one from another textbook, but not similar to your textbook. Anyways, there's 4 different panels to this figure, and we're going to take it step by step, okay? So first, realize that on the x-axis, the horizontal axis here, it's time. We see in days, right? So here's your stereotypical 28-day cycle. Now we know that varies for different people at different times, etc. But on average, it's 28 days. All right. In this top panel right here, it says basically hormone concentration, and we're seeing luteinizing hormone and follicle-stimulating hormone. Okay. So the second panel here, it's showing us what's going on in the ovary. So these are the ovarian events. So let's just take those two things right now. So what we find is, in the first part of this cycle, we see that follicle-stimulating hormones kind of coming up, as it's released from the pituitary gland, and it follows a little arrow down, causes the development of follicles. And we call that, in terms of the ovarian cycle, this is the first of 3 phases. It's called the follicular phase, because that's when the follicles are developing. So it's pretty straightforward. Okay, so the follicle-stimulating hormone causes the follicular phase of the uterine cycle. Okay, now we look at the luteinizing hormone. So luteinizing hormone, we see a big spike of it right here in the middle of the cycle. Okay, and then we see it stay pretty high out here in the second half of the cycle. So the luteinizing hormone actually has 2 jobs. Number 1, that big spike up and then down you see there causes the second of the ovarian phase of the ovulation. The release of the egg comes from the big spike of luteinizing hormone. That's when we know that the ovaries know to release the egg. Okay? Then, those continued high levels of luteinizing hormone cause the corpus luteum to be formed. So we call this the luteal phase of the ovarian cycle. So, luteinizing hormone causes ovulation and causes the formation of the corpus luteum, so we call that the luteal phase. Okay? So does that make sense? 2 hormones cause the 3 phases. Follicle-stimulating hormone does the follicular phase. Luteinizing hormone does both ovulation and the luteal phase of the ovarian cycle. Okay. Now, we said that the ovary is putting out its own hormones, both progesterone and estrogen. So we said that originally, the estrogen is coming from those follicular cells as the follicles are developing. So you see the estrogen levels get higher and higher and higher as the follicles develop. So what does the estrogen do? Who's it communicating with since it's a chemical messenger? So we follow this arrow down here, and if we look at the last panel right here, we're seeing basically the thickness of the wall of the endometrium. Where's the endometrium? In the uterus, right? So the innermost layer of the uterus, this is a layer where that fertilized egg or embryo is going to embed. Okay? I like to think of that fertilized egg kind of like a seed, right? Like a human seed. And if you have a human seed where it's actually been fertilized, take the general biology where they have sperm and egg stuff too. There's a lot to do. And they develop a seed, a fertilized egg seed. And that seed needs to go into the ground where it's going to be supported. It's going to be covered up. It's going to get nutrients from the ground. It's going to grow some roots. It's going to get fluids that it needs, etc. Same thing in terms of the human seed, embryo, zygote. It's going to go down. It's going to embed in endometrium. It's actually going to grow root-like structures, and when it does, it's going to start getting more nutrients, etc. It starts growing faster. In fact, the endometrium actually, just like dirt, grows right over it, forms a little capsule on the top of it, and it embeds right there. Okay? But the endometrium has to prepare for that in each month. So, this is a whole cycle. Those are in a circle, so considering which part of the beginning cycle it is, kind of, arbitrary. But if we consider menstruation to be the beginning of the cycle, this is where, like I said, friends come and stay with you. And so now you're guessing you gotta take all the sheets off you put on there, take the towels away, you're clearing it away, and then you're gonna reset it. Okay? So what happens during menstruation is, from the last cycle, we prepared for guests to arrive. They didn't come, and so now we're going to clean, if you will, get rid of that inner layer, that endometrium. You don't get rid of all of it. There's actually 2 layers of the endometrium. There's a thinner, deeper layer called the stratum facialis that's going to hang around. And you can see that here. Okay? But we've got to build that from there. So we start building back the endometrium again in the first of the uterine phases, which is called the proliferative phase. So if you hear about like an author or something like that, and they are very proliferative, I mean they write a lot, put out a lot of books, etc. Right? The proliferative phase of the uterine cycle is when there's a lot of mitosis going on because the endometrium is going back, and that is under the direction of estrogen. So the estrogen, that surge estrogen is coming from the follicular cells in the ovary, is telling the uterus to start building that endometrium back. Okay, so those cells are proliferating. Okay. Then, ovulation is going to occur up in the ovary, okay? Now, or the ovarian cycle, okay? But we said that after ovulation, those follicular cells become corpus luteum. And the corpus luteum puts out a bunch of progesterone. So if we look at progesterone levels in your urine, they're going up and up and up and up. And they're peaking here when our corpus luteum is created. And so what does the progesterone from the corpus luteum do? So we follow the green line down, and we find that the progesterone causes what's called the secretory phase of the uterine cycle. So we build back the endometrium, but we still need to be more supportive. So if you look at deep in the endometrium here, you see there's more and more blood vessels in there. We see that those white spaces there, those are called uterine glands. Okay? And notice that in the secretory phase, they get kind of wavy like that. Those glands, those uterine glands, or endometrial glands, will actually secrete nutrients for the potential embryos that are embedded there. Okay? Secrete lipoprotein and all kinds of stuff. So when that it embeds in the endometrium, it's just basically surrounded with good blood supply, with nutrients, it's very good for growing. Okay? So, the secretory phase of the uterine cycle is caused by the progesterone coming from the corpus luteum. And until the endometrium starts secreting these nutrients, etc. Okay? Okay. So by that time, the egg should be arriving there pretty soon. Okay? So if it arrives there, it's going to embed, and it's going to embed at a nice, nourishing endometrium, and it's going to continue to develop. Now, you will find in very short order that on a regular cycle, if pregnancy doesn't occur, if we don't do the implantation of the fertilized egg, that thing is going to reset. Okay? So we go to the secretory phase, we're going to shed an endometrium for most of it, we're going to go to menstruation again. But if pregnancy actually occurs, and we successfully have a new individual that's growing in an endometrium, that new embryo is going to release a chemical signal on its own. It's going to release a hormone on itself that's going to communicate back to the mother's body and say, hey, I'm here. Don't go check us out because we were successful and I am here and I want you to know it so that we don't reset the clock on this. Okay? So here's the successful pregnancy. A hormone will be released by the embryo and it will get back to the ovaries of the mother. And what will happen is it will maintain that corpus luteum. Okay? And if the corpus luteum is hanging around, it's going to be pumping out progesterone. The progesterone tells the uterus, okay, keep in the secretory phase, keep a nice environment, etc. And the uterine lining is maintained, and the pregnancy is maintained. Okay? So as long as we keep those progesterone levels high, the uterus is still getting the signal, okay, we're pregnant, we've got to keep up a nice supportive endometrium. Okay? If that doesn't happen, like I said, if there's no signal, the woman, the mother's body is listening for that chemical signal, do I hear an embryo? No. Chemically, do I hear an embryo? No. Then, the whole thing is going to reset, right? There's going to be no signal back to the ovary, and that corpus luteum is going to give up. Well, like I said, it didn't happen, right? So the corpus luteum starts regressing, it turns into a corpus allocation, and what's going to happen to those progesterone levels? See how that's dropping right there? As those progesterone levels drop, and the uterus is like, oh, nobody's telling me to make it endometrium anymore. I guess it didn't happen. So that's when we're going to clear away that endometrium, and that's menstruation. That's the third uterus phase. Okay? So yeah, in terms of the uterus cycle, you see down here, there's two hormones that are in control of the three phases of it. Estrogen is in control of the proliferative phase, where we're building back. Progesterone is in control of the secretory phase, where we're putting out the secretions and creating a supportive environment for the embryo. The absence or the drop in progesterone, if we're not pregnant, causes menstruation. Okay? So again, we see the second hormone controls two different phases. If we have progesterone levels that are high, we stay in the secretory phase. If it drops, then we go into the menstruation phase instead. I told you women were more complicated, huh? Now you got more evidence. Okay, so questions on that? So the important thing we have here, right, is basically 10 things you need to know. There's 3 phases of the ovarian cycle, right? There's the follicular phase, ovulation, and then the luteal phase. There's 2 hormones that control that, called stimulating hormone for the follicular phase, luteinizing hormone for ovulation, and then for the luteal phase. Luteinizing hormone, luteal phase. So that's 5. The ovary puts out estrogen and progesterone. They control the uterus. So the estrogen controls the proliferative phase that's building up again. Progesterone takes things into the secretory phase where it's secreting. And then if the progesterone level drops, then the uterus doesn't get that going anymore. You're going to go into menstruation, and then you're going to get clear. We're going to reset that off again. Okay? So, you need to know the 3 ovarian phases, the 3 uterine phases, and the 4 hormones that control the level. So no question on that? Clear as mud? Okay. So here's your related topic. So, let me slide coming up that talks about pregnancy, and if you don't want pregnancy, various types of contraception ways to not get pregnant. Right? So one of those ways, right, is birth control pills. So birth control pills, how does that work? I'm taking the pill, I'm not supposed to get pregnant. How does that work? That's like putting some sort of like iron on my uterus, like nothing in there, or how does that work, right? So what happens in there? Remember that when you're pregnant, okay, estrogen levels are going to stay high because the corpus luteum is going to hang around. And you're going to get support and then develop the embryo. Now once that embryo gets big enough and it turns into a fetus and that placenta forms, that placenta actually starts secreting its own hormones in order to maintain pregnancy and encourage development, etc. Okay? And it will, again, take over the role of maintaining the uterine lining. So what happens there is throughout pregnancy, progesterone levels stay high like that. It maintains your lining, the uterus is bigger, the embryo is developed, etc. But when progesterone levels are high like that, that actually inhibits the whole ovarian cycle, right? We're pregnant. We don't need to be popping out eggs on a monthly basis. We've got 9 months of just working on the one that's there. So all those ovarian cycles and uterine cycles get suspended for those 9 months. Because the progesterone levels stay high. So, in terms of birth control pills, the chemical that's in there is synthetic progesterone. So, for 3 weeks of the cycle, you take 2 pills, and those have progesterone in them. So what you're doing is you are artificially elevating your progesterone levels and fooling your body into telling them they're pregnant. So, no ovulation occurs, etc. The uterine lining is maintained, stuff like that. Then, unfortunately, you change the green pill. Oh, okay. Green pills, placebo, nothing in them, no hormones in them, etc. So what happens is, 3 weeks, high progesterone levels, no ovulation, etc. Then, you stop taking the progesterone levels drop. You know when progesterone levels drop, that's the signal to the uterus to go into menstruation phase. So, when you change over to those pills, menstruation starts shortly thereafter. And then you go back to the cycle, fooling your body with pregnancy. No ovulation possible, no eggs to be fertilized, no pregnancy. So obviously there are other side effects. Progesterone and estrogen that have a variety of effects on the body, fooling your body for a long period of time with these hormones from outside the body can be a problem, just like testosterone. Guys who work out, take testosterone. There are other side effects like that as well. But that's how it works. Okay, so that whole cycle that we're talking about will continue again and again each month until menopause occurs. And in menopause, those hormonal levels that we keep talking about drop. So all stimulating hormone drops, follicles don't develop, estrogen doesn't go up, uterus doesn't go through cycles, stuff like that. some of the secondary sexual characteristics and metabolic effects of those steroid hormones also are developed. So hot flashes and different things that are going on. So a lot of people, a lot of women at menopause will actually start taking estrogen to try to keep them lean minimal level of that, even though their ovaries are no longer putting it out much. Okay. So